Okay, so good afternoon everyone, and hope all of you are well. Okay, so let's continue that portion we had discussed. So last day I have told you about how to represent the formula. Yes, Subho Vijaya to everyone. Okay, especially Raima has offered. Yes, Suhrid, Subho Vijaya to you also. So last day I have told you how to write the formula and also practiced some formulas, that is how to represent the formula. Now the another part, that is we have practiced from the formula, that is from the symbol to the formula, and another in the reverse way you have to be, it would be, suppose from formula to name. Can you do it? Can you do it from formula to name? This is aluminium and this is sulphate. So it would be aluminium sulphate. Okay, not sulphide, it is sulphate. NH4Cl. This is ammonium chloride. It is not ammonium chlorine. Okay. Another one, that is Al, delete it, calcium. This is calcium hydroxide. So from name to the formula, and okay, now here just follow that the chart. The chart I had given to you, that follow that chart. There is S2 minus, it is sulphide. S2 minus is sulphide and SO4 2 minus is sulphate. If you carefully follow that part, then you can distinguish in between these. Clear? S2 minus is sulphide and SO4 2 minus is sulphate. Okay. So from formula to name and from name to formula, both these two are important. Now come to the section 3.5 of your NCERT book, page number 39 in my book. The topic is on molecular mass and mole concept. Molecular mass, or the similar term is molar mass. Okay. So the molecular mass, so it would be the mass of the molecule in overall. Now just I am writing down one general formula, AX by Cz. Here X, Y, Z are the atomicities of the individuals, that is A, B and C respectively. So the molecular mass and also the atomic mass is required here. Atomic mass of A is equal to A small a, capital B equal to small b, and capital C equal to small c. So the molecular mass is equal to, the mathematical form will be small ax plus small by plus small cz. Okay. So this is the form to calculate the molecular mass. So for this, what we have to know? So the atomic mass we have to know, and it will be multiplied by its the number, the number of the atoms in that molecular formula, and it is represented in gram. So the, what is the definition of molar mass? The molar mass is that the when the atomicity and where the atomic mass is multiplied and then summed up to get the molecular mass in gram is called the molecular mass, or the overall mass of a molecule is called as molecular mass. So the overall mass overall mass or total mass of a molecule is molecular mass. It is represented in gram. Okay. So total mass of a molecule is molecular mass. It is represented in gram. Yes, atomic weight and atomic mass is same here. Atomic weight and atomic mass is same here. Okay. So this is the molecular mass. Now I am taking one example, glucose. Glucose having the molecular formula C6H12O6. Now just from the general form, it is A, it is B, it is C, and it is X, Y and Z. Now the carbon, the atomic mass is 12, hydrogen, that relative atomic mass, or in U, that is 12U, this is 1U, and it is 16U. Okay. Now 12 into 6 plus 1 into 12 plus 16 into 6, overall U, that is equal to 72 plus 12 plus 96, 180U. Okay. So the molecular mass of glucose is 180U. So by this way you will calculate this. Suppose it is given the calcium carbonate. Calculate the molecular mass of calcium carbonate. Calcium carbonate, that is CaCO3. Now the atomic mass of calcium, yes, you can take the decimal, but here when we will represent it, then we will get the full number, that is carbon equal to 12, not the decimal point is here, is deducted here, because as it is a relative to the mass of that carbon atom, because the carbon atom, the mass of individual carbon atom here is a very lot fraction. Yes, as it is the unit, that is 12 gram or 12 U. U is the in case of atomic mass unit, but when we will represent it, it will be on gram. So 180 U, it is the one molecular mass of glucose, and also when it will be represented in gram, then it would be 180 gram. Decimal number. Okay. So when we will have discussed the atomic mass, then it would be taken as the mass of that atom divided by mass of one atom divided by 1/12 of a carbon 12 isomer. Okay. Now 1/12 of carbon 12 isomer it is a very small unit, that is the unit is, the numeric is very small. So when we will divide it, then we will take the approximation to the nearest whole number, because if we take the decimal, then there is a difficulties in calculation. So we will take the nearest decimal. So for this, the atomic mass is taken in the whole number, 11, 12, 6, 7. Okay, so calcium carbonate, calcium, what is atomic mass? That is 40 plus carbon 12 plus oxygen 16 into 3. Okay, so 52 into 48, it is equal to 100. So 1 mole of, 1 mole will become later on. So this is the molar mass of calcium carbonate. So in this way you will calculate the molar mass. Now coming to the next part, what is mole concept. So, the mole is that it is defined as, we can define mole. Okay, so formula unit mass, molecular mass already discussed. And what is formula unit mass? It is the formula unit mass is the compound for ionic type, ionic compound, when there is no definite bond length is there and it is only due to the electrostatic interaction. That means in ionic compound, one compound, that is sodium chloride. Sodium chloride is an ionic compound. Here the two cation, one cation and another one ion, that is Cl minus and Na plus. These produces two poles and electrostatic interaction, interactive force, and this is the reason for its crystal structure. So, for this type of compound, here only the formula mass is used for ionic crystal. Next, the mole concept, as 1 mole of any species is, that is, it may be atoms, it may be molecules, or it may be ions, or any particle, is the quantity in number having a mass equal to its atomic or molecular mass in gram. Okay. So, in 1 molar mass or in its atomic mass, the number of its atom or molecule. Suppose in calcium carbonate, we have calculated it is equal to 100 gram, just we have calculated. So, in 100 gram, how many molecules of calcium carbonate is there, or in 180 gram, how many molecules of glucose is there. Okay. So, this is the 1 mole, and later on it is proved that all, that is the 1 mole in the same conditions, or 1 mole of any substance contains a fixed number of molecules or atoms or ions. The fixed number of molecules in 1 molar mass. It may be its in the molar form, that is molecular form, its atomic form, or its ionic form. So, 180 gram of glucose contains the molecules equal to the molecules contains 100 gram of calcium carbonate. It is equal to 6.022 into 10 to the power 23. It is abbreviated as Na, or Avogadro's number. Okay. So, 100 gram calcium carbonates contain this number of molecules, 180 gram glucose contains this number of molecules. So, in the reverse way, we can call that 6.022 into 10 to the power 23 number of atoms, molecules, or ions weight is equal to 1 mole. So, 6.023 into 10 to the power 23 number of atoms or molecules or ions mass equal to is 1 mole. So, the 1 mole chair, it is equal to 6.023 into 10 to the power 23 number of chairs. 1 mole chalk, that is equal to 6.023 into 10 to the power 23 number of atoms. 1 mole of carbon atom equal to 6.023 into 10 to the power 23 number of carbon atom. 1 mole carbon equal to 1 molecule of carbon equal to 6.02322 into 10 to the power 23 molecules of carbon. Okay. So, this is the general form. Yes, no, this is not only for fluid, because there is no clear distinction. Here the volume is applied there in case of fluids or gases. Now, Coming to the next part, just take one yes, for gases there one abbreviation is there, one condition should be there: at same temperature and pressure. At same temperature and pressure, it is also true for gases. At same temperature and pressure, yes, STP. Okay. Now come to the example, that is 2H2 plus O2, that is 2H2O. Now from that we can tell that here 2 moles of hydrogen, 1 mole of oxygen reacts to produce 2 moles of water. In the same way, N2 plus 3H2 forming 2NH3. So here 1 mole of nitrogen, 3 mole of hydrogen produces 2 moles of ammonia. Okay. So these are the general form. Here no numeric means 1 is there. So 1 mole of nitrogen reacts with 3 mole of hydrogen forming 2 moles of ammonia. In the previous one it is 2 moles of hydrogen reacts with 1 mole of oxygen to form 2 moles of water. If it is a different CaO plus CO2 forming CaCO3, here 1 mole of calcium oxide reacts with 1 mole of carbon dioxide to produce 1 moles of calcium carbonate. No, you need not to balance, but if you can do it. So 1 mole of, it is not essential here, 1 calcium carbonate, calcium oxide 1 mole carbon dioxide forming 1 mole calcium carbonate. Clear? This is about mole fraction, that is the mole. Now for gases I told you that the same temperature and pressure. Now you will complete the questions regarding to the calculation of molar mass in page number 40 and also the formula unit. Now just follow that: Na2O, ZnO, K2CO3, these are all calculate to the molecule, the formula unit mass, and for the covalent molecule it is the molar mass, but the molar mass is given, not exercise, it is the in text question in page number 40 given in the blue form. Now come to that chart in page number 40. This is a very important part. One mole, just point out at the first line, 1 mole of carbon atom, 1 mole of carbon atom, not molecule. So in the left side it is 6.022 into 10 to the power 23 number of carbon atom, and in the right side it is the mass, that is 12 gram. So 1 mole carbon atom is equal to 6.022 into 10 to the power 23 carbon, number of carbon atoms. In the same way it is equal to 12 gram of carbon. So these three are related to each another. So we can correlate these two. So 12 gram of carbon contains how many molecules? This number of contains carbon atom contains 6.022 into 10 to the power 23 carbon atoms. In the same way 16, okay, let us come to the more example. In the next, 1 mole of hydrogen atom. So 1 mole of hydrogen atom also contains 6.022 into 10 to the power 23 number of carbon atoms, and hydrogen atom, and it is equal to 1 gram of hydrogen, because it is with respect to the hydrogen atoms, not molecules. But it would be molecules, then 2 gram of hydrogen molecule contains 6 point this number of hydrogen molecule 6.022 into 10 to the power 23 number of hydrogen molecule. So, 1 gram then hydrogen atom, and it is equal to the same number, that is Avogadro's number, and when it would be mole, then it would be 2 gram of hydrogen equal to 1 mole of hydrogen contains 6.022 into 10 to the power 23 number of hydrogen molecule. Okay. So, this is about the mole concept. Who discovered mole? That is Oswald discovered the word. It is a Latin word, heap or pile. The mole meaning a substance may be considered as a heap of atoms or molecules. Now come to the in-text problem, example 3.3. Example 3.3, calculate the number of moles for the following: 52 gram of helium, 52 gram helium. Now, helium is a monoatomic and its atomic mass and the molar mass is the same. So, helium equal to 4 gram as it is given in gram. So, the moles, number of moles equal to given mass divided by molecular mass. Okay, so given mass this is 52 gram and molecular mass, that is 4 gram. So, 13 is the number of moles. Clear? In the next question, that is 12.044 into 10 to the power 23 number of helium atoms. So, again in the how many moles? 6.023 into 022 into 10 to the power 23 number of atoms equal to 1 mole. So, the example given 12.044 into 10 to the power 23 number of atom equal to 1 into 12.044 into 10 to the power 23 divided by 6.022 into 10 to the power 23. Both are cancels out and it becomes 2. So, this is the two simple problems regarding to that. Okay. So, that is all about the mole concept.